So we are happy that lot more interactions are coming. Also, we are all aware that accidents, whether fire or electrocutions, they are happening mostly in LT and domestic premises nowadays. So our people, Mr. Gopa and Krish, have already explained about the protection measures for the hazards which is occurring inside our premises. That is down the protective device on our current using equipment. But now I am going to deal with the hazards that happens external to our premises. For example, there could be an earth fault in the distribution transformer or in our own transformer due to winding fault or lightning arresters, short circuiting, something like that. A surge, an earth fault, during the earth fault a surge will be available. It will vanish depending upon the protective devices available at the substation or the ST side protective devices. And before such fault clearing, there is always a possibility of the over voltages that can be impressed upon the LT, the secondary side current using equipment devices. Some earth potential rise will always occur during the earth fault. So that can impress a over voltage across your equipment or the metallic frame and the general mass of earth where you can happen to touch. Such type of hazard only I am going to elaborate now. Okay, here I am going to, the contents will be integrity of TNS and TT earthing arrangement, coordination for fault within and external to the consumer premises, and stress and fault voltage from HV side into the consumer premises, then tolerable touch voltage due to an earth fault, and how these challenges are mitigated. Of course, IS 61936/2021, the specific part pertaining to the over voltage alone, because 61936 deal with so many other aspects like fire safety measures of transformers equivalent to 10,028 or IS 1646. So those parts will not be explained here. The specific single point is the over voltage occurring in the ST premises, ST side. So you may be aware, because of the previous sessions, the TNS and TT systems, and any fault occurring in an equipment, the earth fault current will be flowing through the TNS system, protective earth conductor, and this linking makes it as a TNS system. Instead of major fault current flowing through the general mass of earth, almost 99.9% is flowing through the protective equipment and this interconnection. So what we are having is the TT system. In most of the installations, we are having the TT system. That the link that I have shown the previously is missing here. But unfortunately, what we are having is the fixtures, these connections. This is inadvertently, this is not knowing to us. We are having a cable armor or the bus duct which is in turn connected to the transformer body, and the transformer body and neutral electrodes are connected. Ultimately, what we are having is, in practice, a TT system you can say it is an inefficient TNS system. This is neither a TT system nor a TNS system. It's an inefficient TNS system. So here, this is the only slide that I am showing regarding the TT and TNS, because it is being dealt with more by our GOPA. Then, overload protection is already explained in IEC, and the only point is, as per class 8.6.1 of IEC 60898-1, this is the IEC which describes about the characteristics of MCB. The thing is, tripping characteristics should be such that they ensure adequate protection of the circuit without premature operation. For example, if you want to use your appliance like, say, your electric appliances in your home, like mixie or other things, the MCB should not trip. So that's why they provide type curve C, B, and D curves. So that is the thing. And earth fault and lightning protection is dealt with separately. So fault external to the consumer installation is now going to be touched upon. Then how these things happen. For example, this is the figure available in IS 732, and you see this is the distribution transformer or your own transformer. Here there is an interconnection. This is the body earth of transformer. This is the neutral earth of transformer. These two things are interconnected. In a situation 1, it is interconnected. And there is possibility at the consumer premises. This will be interconnected or isolated. In TT system, there is no connection. In TNS system, there will be connection. So for these two configurations, whether interconnection of body and neutral and interconnection here, that is TT or TNS, what will happen? What will be the voltage impressed in the consumer's equipment or consumer persons? So this is the thing that I am going to explain. For example, if it is TT, suppose your equipment or your installation is in TT, then at the connector, I will show in the another slide to provide more clarity. Suppose if you have a TT at the consumer premises, that is at the LT premises, at the secondary side of transformer, and you are having an interconnection between the frame and the neutral, then there will be an voltage impressed at the consumer equipment. The voltage will be high. At the connector portion, the voltage will be referenced because of absence of interconnection. The voltage will be high, but person will be protected. This is the TT system where the person will be protected, but his equipment will not be protected during such interconnections. Another thing, so let us see what will happen if it is a TNS system. Here it is connected and your LT side is a TNS system. Here the person will not be protected and the equipment will be protected. So in both situations of interconnection, the transformer will be protected. The impressed voltage will be less because of interconnections. The voltage will be referenced. And see, suppose if we see that there is no interconnection, in the absence of interconnection between the body and the neutral, the voltage will be impressed more at the transformer LT. The LT winding will be impressed more voltage. And you will be safe. The person as well as the equipment will be safe. In another situation, this is open and both are safe, but the transformer will be impressed a high voltage. So how to overcome from these situations? For example, we do not know, this is not in our hand. I will show in another slide how this will be mitigated. Here, for example, yes, this is a situation where you have the distribution transformer. You can have the neutral earth terminal, which is bound at the structure. In another area, there is one more substation, different substation, where the neutral will be strung at the insulator. So there won't be any connection. So there are two possibilities. The transformer will have a neutral connected to the body, or it will not have a neutral connected to the frame, to the neutral. Here, what will happen? How to address this issue? Here, number one, this is the table. This is the table as per IEC 61936, part 1. Here, we have to contain the EPR requirement. For the EPR requirement, for example, if it is a TT system, as already shown in the previous slide, you will not be subjected to the touch voltage. So you are safe. But the equipment voltage will be high, and it is depending upon the time, duration of tripping of device, it will vary. Less than 5 seconds, it can be permissible up to 1200 volt, and beyond 5 seconds, you are permitted to have 250 volt. So this is based on the equation. This is earth potential rise is equal to the factor. There is a factor and UTP. This UTP is the touch potential. I will show in the next slide. In the morning, Gopa also shown. So we have to calculate the EPR based on these two things. F is a factor and UTP is derived from a graph from figure 28 of IS 732. I will show. See this figure 28, morning Gopa has shown. So, for example, for 1200 volt, see 1200, and for less than 5 seconds, this will be the value. This is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. Say somewhere around 70 to 80 volt. So it is very tough to contain the EPR limit below this voltage unless we have a very good earthing system. Here, for example, for a typical 250 kVA transformer, assuming a 5% impedance and secondary voltage of 433 volt, the primary 11 kV and secondary current is 333 volt. The primary current will be around 13 ohms, and short circuit current based on the percentage impedance will be 20 into 13, around 260 ohms. So for this 250 kVA, that 260 ohms will be reduced because of your TT connection and a TNS connection. In case there is a TT connection, a typical value of fault current at the secondary side of transformer will be 217 for this much of ohms. And you can have a 1200 volt easily managed by this 5 ohm consumer using TT system. In TNS system, we should have this 0.4 ohms. It is again it is possible in TNS system, and this is the value that can be attained. For 0.4, it is not attained. Suppose if you go to 0.3, it's a resolution. If you go to 0.3, we can easily achieve this permissible touch potential. This is 101 volt at 3 seconds based on the previous graph. So, based on this, what we have done? We have done in an installation. This is the point of supply, and the neutral is connected. We have provided a meter to measure the current when our neutral is connected. See, for example, in this house, this neutral is connected. See, this neutral is connected to the supplier neutral. This is a TNS system. When this neutral is connected, even after switching off our home, we will be having a leakage current. It is showing 0.43. See video. See video coming.
Switch off my home power.
Okay. This is a meter that we have connected to show what will be the condition before switching off and after switching off the supply to our home. Even after switching off, the same home is same current is leaking through. It is not the current leaking from the consumer premises. It is a current from the leakage current from the adjacent premises because of the earth electrode. Because of this earth electrode, it is going towards this and to the source. So, if you connect without knowing the condition of distribution transformer and the suppliers or your own transformer, it is very tough to connect, to go into the connection. So, the possibility of mitigation is two things. One, the consumer do not have any mechanism to check compliance, because the earth potential rise is dependent upon the fault current as well as the distribution transformer's earth electrode resistance. You don't know what's the fault current, what is the earth resistance value maintained by the supplier. And that's why the IS class 4.5.2.2.3 insists that supplier is responsible, distribution company is responsible to maintain, but practically it doesn't happen. So, whatever the standards or codes or rules available, you safeguard yourself. Because I am particular about we are doing so many interventions or installations for the industry, for IT and other things. But have we ever cared of our own premises, whether we are connecting our protective equipment, earthing conductor to the transformer, to the supplier's neutral or not? So, the thing is, there is no other way. You don't have idea of supplier's interventions, and in that particular situation, in the interconnection at the transformer, we assume that there is some interconnection. The worst case scenario, we assume there is an interconnection of the transformer, because it happens. And you adopt TT system at the ME side of consumer installation. This is the arrangement adopted mostly by the consumers throughout the country. And you should also comply with the table 5. There is one table which describes that I have already shown the table. So, you comply with the table 5 and adopt that TT system. Then another thing is, in case of TNS earthing, it is essential for installation like hospital, but you should have TNS system for installation like hospital or IT, computer industries, as well as industrial places where sensitive electronics equipments are involved. You must have TNS. So, what we have to do is, you have to adopt a global earthing system, so that or observe. If you observe a global earthing system, you don't bother. If you have, you don't have. If there is no feasibility to connect the rebar earth or foundation earthing and other things, you should observe table 5, which is very tough. So, global earthing is becoming an essential component, essential factor in the case of installation involving the necessary TNS earthing system. So, observation of table 5 is not at all required if you go for global. We have actually visited, I visited along with Mr. Gopal to Hyderabad on a specific issue. We found even in that location where the soil resistivity is more than 500 ohm meter, it's somewhat a rocky soil. with the global earthing system. Type B earth ring run around the building for lightning protection. So all the things getting interconnected, we were having measuring earth resistance of 0.1 ohm. This, if you have a 10 kA, for example, a 250 kV installation or 500, even 1000 kV installation, you have a 10 kA rating, then it's a case of 0.025. But you have your own HT breakers that can be tuned. So you can have enough fault current to get the system protected. The problem is the protection. When the transformer is yours, you can dictate. You can have your own global earthing system, one more protection on the ST side, LT side, etc. But if it happens to be a LT installation, a transformer of distribution transformer of supplier, and you are having a small workshop or small computer center or IT center, then you should adapt this TN system and observe table 5. So, so this is the thing that we people forget about the safeguarding ourselves and how where the neutral is connected, is to be connected with the body or it should be isolated. There are so many confusions that we will deal with the, in the tomorrow session, where how to mitigate your sensitive electronic devices during conducted or radiate emissions. That will be taken because of paucity of time. I think we can have it tomorrow. We can have it tomorrow. And there is one more session, Mr. Gopa is waiting. So with this, I would like to wind up. So I would like to recap that over voltage due to earth fault occurring at the HT side. You don't have control of your person, your equipment, unless there is a very good global earthing system. This is the final tips that I want to give. Thank you for your patient hearing. Really, we are learning. This session is somewhat different from this edition. Compared to Delhi edition, we are having so many interactions and it is getting raised and solved by yourselves. Thank you all.